I think we are breaking the speed of light with Marco using a PC. And that's not supposed to be true. Okay, so, well, thank you for being still here on Monday, which is, in fact, the most important day, especially for the people who have organized this meeting, because that's the day where we get rich after these very, very dense 4 days. And so we have the honor to start with a keynote from the European Commission. And so Panagiotis Balamanis will talk to us about what the European Commission is doing, especially in the research and development part of the European Commission. You know that they have the Copernicus part and then also research and development. And you probably know our DG RTD because it means Framework Program 1, 2, 3, 4, 5, 6, 7 and Horizon Europe. So Panos, you have, I think, a lot of time to tell us about the European Commission. How much time did we give you? 20 minutes. Thank you.
Thank you very much, Jerome. Good morning to everybody. Thanks again for this invitation. Happy also to be here, physically in this last day of the conference. So let me start perhaps by saying that water has been an important component in the various, let's say, framework program that Jerome just mentioned a few minutes ago. This is, nowadays is a 7-year, framework program which sets priorities and funding also in particular. This is important for different type of activities, for individual researchers, fundamental research, for collaborative projects, and also the activities also for the uptake of research results, the business opportunities. So water has been an important component of these programs because these programs have also strong environmental also focus, and of course water is a key element. But on the other hand, water is, as probably you know, is an area where there is a strong, let's say, policy at the European level. We have, the Water Framework Directive, which tries, to have a kind of river basin approach management, for water resources. But also we have also individual type of policies dealing, with drinking water, with wastewater treatment, with water use, flooding, also the flooding directive. So this is also an important area. So as you can see here, these are the figures for, let's say, the previous framework program, which is called Horizon 2020, which was 2014, 2021. This has been already finished. And there you have, a complete, picture of the type of also of the funding which has been given. So as you can see, this is more than 1.3 billion has been already dedicated. And can you see that water, different type of issues, which have been covered there. And you can say that, in issues in this team working, with global water cycle or water, management, there was a strong component, of Earth observation activities, observation and monitoring. Here is just, a few examples to give you, a flavor of the type, of Earth observation related also projects which have been funded here. So we have several projects trying, to combine Earth observation methodologies with hydrological models, for instance, and in situ measures like, water sense. We have CERTO, which is a project trying also to harmonize, water quality data, phytoplankton, suspended sediments, dissolved organic matter, for its, comparing with also services for transitional water like lagoons, estuaries also, and large rivers. We have also projects trying also to combine, machine learning algorithms with advanced data simulation techniques like prime water, and integrate also satellite imaging spectrometry for delivering, advanced water forecasting services, in particular also for floods. And we have also projects, for instance, dealing with operational water quality emergency monitoring services, and also project trying also to integrate Earth observation data and in-situ monitoring with hydrological models, also to develop a kind of decision support system, which can also forecast the water flows and quality data in reservoir, which then also can be also used for the optimization of wastewater treatment plants. So you can see a wide range of applications and domains which has been also used. But most particularly, I think this is also a major project which is now coming also to the end, and I would also recommend, I don't know if, I suppose that several of you perhaps, you have been also linked with this project. So this project started also from the, let's say, the current limitations of the current climate services with regards to water, because we know that there is no, let's say, dedicated climate service of water. Water is part on different, in Copernicus services. But the problem is that these Copernicus services, are operated separately, and very often they have their own specific purpose. So they are not updated to have a more systematic, focus on the water cycle, in particular, in both from regional also to global scale. And this water force analyzed the different, needs of different also users from the coming also policymakers, also researchers, but also the industry, the business sector. Trying also to determine gaps in the current, Copernicus water services, and also trying also to evaluate also the technical capabilities of present and future also Copernicus sensors, with a view also to provide also a roadmap. And so this project has now has already provided draft roadmap, has been also presented and discussed in several also frameworks and conferences. Coming back to the current, this is the Horizon Europe program, which is 2021-2027. This is, a very big, from the financial point of view, framework program with almost 100 billion euros. And here you can see also the structure, and you can also recognize what I have said before. You have different actions where, also different type of activities, what we call the pillar one, which is more, this is science driven. This is, also researchers also, I would say, driven. This is, we have also the European Research Council, but we have also the Marie Curie actions, for PhD, for master degrees. We have also the research infrastructure, and we can also say that Earth observation is also a kind of research infrastructure. You have also the pillar three, which is, as I said, this is more, we call this European Innovation Council, is more for SMEs, is more for the business, is the uptake, of research results, for market business applications. And then the main bulk is what we call the pillar two, what we call now the global also challenges. And you can see here we have what we call different clusters. They have numbers. For example, cluster one is the health, cluster two is the culture, and the cluster 6 is about, food, bioeconomy, natural resource, agriculture, and environment. And here is, let's say, the bulk of water research activities nowadays. So within this cluster 6, as I said, we tried also to have a very systemic also approach on water, trying also to strengthen also the linkages with the other parts of the Horizon Europe, because as I said, the pillar one, you have, a lot of, research-oriented activities, but also within the clusters, we have also cluster 6, but we have also the cluster 4, which is about, remote sensing, is about, space application. There, for instance, we have the Copernicus-related also calls. So we tried also with our cluster 6, trying to have a more comprehensive, systemic, let's say, approach, and try to see also how, trying also to make clusters of projects in different areas also, and trying also to also incorporate, elements or Earth observation developed, through the various parts of the work program. And as you can see here, in the first 4 years of implementation, there are more than 200 million euros, which only within Cluster 6 have been also dedicated to water. And here is just to mention also a few ongoing projects that just started recently, and these are projects that we have also intend also to bring also in synergies with the activities of the European Space Agencies in this cluster, and we are also in contact here. For us, you have also the so-called SOS water project, which trying also to collect relevant Earth observation and data sets also for Copernicus, and try to review all the relevant in-situ data sets, from different case studies, and both trying also to assess and compile, important data set attributes. And then trying also to, I think this is what very important, is also to determine, mismatches between, water resources challenges and Earth observation availability. Another project which I think is also worth also to mention is this STARS for water, which trying also to provide also to the different stakeholders a new generation of data services and data-driven models which are tailored to the needs. And here you can see the different also activities and which are applied in 7 river basins across also Europe. And I think it's very important they try also to improve also the accuracy and resolution of regional scale projections of water resources availabilities from 10 to 1 square kilometer also grid. And also, of course, is trying also to promote the, let's say, the transferability of these data services and tools to provide also guidance, but also capacity building activities also for the various end users. Let me also highlight, and this is also still an open possibility, because in the work program calls on 2024, we have annual calls in the project. And I would like also to bring your attention in this call, which is still open. I think the deadline for submission is February next year. And here, as you can see, this is a very ambitious project. We have more than 15 million euros, which are dedicated. We expect that an average project could be about 5 million euros. So we expect to have perhaps 3 projects also funded in this area. And as you can see here, we can try to develop a kind, what we call a whole system monitoring approach, in particular to address water quality in urban areas. So this is very important, also linked to what we call the Zero Pollution Action Plan. This is zero pollution is one of the activities of the European Green Deal of the Commission. So this is also about also monitoring observation of water pollution. And here, as you can see, we call explicitly also in the last bullet the possibility also to explore and consolidate also the capabilities of real-time monitoring water quality also through, of course, Earth observation technologies and other also machine learning, artificial intelligence, and digital data spaces. So this is also good for your attention, because what is important here is to strengthen that these are collaborative projects, trying also to build consortium, not only scientific consortium, but also bring also together, the links between, end users, policymakers, industry. So this is very important, for instance, to have this in mind if you are interested also to apply to this type of proposal. Another also important elements which I would like also to mention, and these are, other additional, let's say, funding possibilities also for researchers within what we call the European partnerships. So European partnerships is a kind of initiative at the European level where the Commission is committed also to support member states when they have already coming together to bring also their national funding sources in a more, coordinated way, trying also to align also their policy and priorities in different areas. And this is the case is that we have, the different partnerships which are very relevant. We have also what we call the Water for All. This is water security for the planet partnership, which build also has also a very ambitious also framework program and also a timetable. This is running for 7 years. And here, as you can see, there are also funding. Also, the Commission is committed 126 million in addition to the member states funding. So overall is about 400 million, which are generated also together for different type of activities, as you can see here. So this is the particular also the part B, which is what we call also joint transnational calls, where member states together also with EU funding also put some joint transitional calls. And just to give you an information, the first transitional call in 2020-22 was focused also on extreme events, adaptation also to extreme events. So these projects are now going to start. So I'm sure that there are a lot also of projects dealing also with application of Earth observation. And there will be also several calls. There has been a second call launched on what we call environmental ecosystem services also approach. And there will be also additional calls in the last years. But as you can see, there are also different types of activities which are promoted with these partnerships. And this is also the what we call the Pillar C, which is very important, because this is also speaks about, is about, bringing together, the what we call the science policy interface, trying also to coordinate better, the flow of information, of availability of solutions to the policymakers. And there, this is a strong also data sharing strategy, which the Water for All is also going also to undertake. And I think it will be very important also to link also your community also with this activity. So I will be pleased also through also the co-chairs to trying also to make strong the links with this Water for All, because here you can see they have also a kind of ambitious, let's say, idea also to try to create a platform, for this water-related data. And of course, this has to be linked with Copernicus, with different other activities, not, to start from scratch. And so this is the challenge, how to better also link all these related activities. Another important also related partnership is what we call the Sustainable Blue Economy Partnership, which is links more about, this is the similar type of partnerships. And here you can see is linking more about, the sea perspective. And then, these two partners can also allow us to have a more, let's say, holistic approach from, inland water also to coastal water to the oceans, to have also this overall, systemic also approach. And as you can see here, there are different activities which are also related, in particular, the digital twin of the ocean that I will also mention in the next. Another also, one of the novelties of this Horizon Europe is another initiative which we call, missions, the European missions. And these European missions are a way, let's say, to address, specific goals in a very specific set time frame. And there have been 5 missions which have been proposed, that missions related to the climate change adaptation, to the cities, also to the soil and to cancer. And one of the 5th mission is related to what we call the mission Ocean and Water. And here, as you can see, the target is also to restore our ocean and waters by 2030. And here you have also the objectives. There are 3 main goals. We can see on the left side of the slides. And then you have also specific targets which are also extracted, for the different policies which are related to the also to the water and oceans. And here is, the type of activities which, so these are additional calls. And what is important is this missions also trying also to have also the citizens also involved from the beginning in the design of the priority, but also in the implementation of the framework, in relation also with member states, and also trying also to mobilize also additional resources from other policy areas of the Commission. For instance, we have the structural funds. We have also live projects which are more applied oriented, and also member states also activities. And within this, as you can see, one of the enabler is also the development of this digital twin of ocean. So this is, this is the idea to also to develop a kind of data-driven simulation, which using also real-time and historical data of different components, from different also sources, satellites, also the ocean sensors, but also, the research vessels, etc., and trying also to have a kind of representation, of the physical components, of the ocean system. And this is something which is supported through dedicated calls within the European, within the mission ocean. And what is also very important that in addition to that, the mission is also trying also to develop a kind of freshwater, inland water dimension. Recently also the 2023 issue a call for a kind of coordination support actions to reflect how to build, the inland water component within the digital twin of ocean. So this is also to have a more, let's say, what we call a combined hydrosphere, digital twin capability. Let me finish, with highlighting, some what are, the future perspectives. So here I would like also to stress to what we call, short-term financial perspective, in particular within the context of the remaining 3 years of Horizon Europe. So these are, as you can see here, these are some gaps which we have been identified, take into consideration what has been already foreseen under Horizon Europe within Cluster 6, and what has been also funded up to now. And here you can see some relevant also actions. So the particular also large-scale implementation. I think this is something that we are convinced that this is something which is also prevents nowadays also although there have been a lot of achievements, from the implementation of different policies, the Water Framework Directive, still, the potentials are not explored by the member states. Still, we have problems. And I think we consider that one of the main also, there have been already identified some regions for that. But one of that is that we lack a kind of systematic, coordinated application of the outcome of research projects from policy regions. And this type of, large-scale implementation can also help also to bridge also this gap. And here we have actions related, to the resilience of water systems. So digital technology, the digitalization in the water sector I think is a key. This is also in relation to the different agendas, the digital Europe, which is one of the policy areas. So these are the areas that we are going also to support in the next years. And I think what is also very important is that there have been also recently, in particular also this year, there have been some significant also policy developments in the water area. We had, early this year, as this is the UN Water Conference, which, after so many years, it seems it was the first water conference at the UN level since 50 years. So this is, created, a big momentum, put already also water high in the agenda. And also in this year also there have been also the European level, there have been also different also policy developments. You have seen here the European Council also highlighted also the importance of water. The European Parliament also adopted resolutions on droughts and had also this year also a plenary discussion about water scarcity, water security at the European level. We have also the European Economic and Social Committee, which is also a consultative body, and recently called what they call, a blue deal also for Europe. And last but not least, also the President of the Commission also announced in his, speech of the year last September, the adoption of what they call Water Resilience Initiative. for this year. So this is, I think, a very initiative which is still, under development. We are not yet, the main components, but I think what will be important, this provides also an opportunity to build also their explicitly a water research and innovation agenda, which can also support this implementation, this initiative. And so we are looking also forward also to see also the outcomes also of these workshops, also to help us also to develop, the strategic dimension of this policy. And with that, I would like also to finish my presentation, and thank you very much for your attention.
Thank you very much. It was very interesting. You showed us the big ambition of the European Commission and in many aspects. I have a question. You insist and you said about the data sharing and that it is very important, that is a commitment and so on. But we know also in our sector that it's not so, first of all, it's not so easy. We have some, I would like to know how the European Commission interact with other international organizations that are trying indeed to make that happening. I mean, data sharing. I just can give you the example of the GRDC, the Global Runoff Data Center, which is under the hand of a German institution. And they say to me, and we know, and we all have seen that it's very complicated for them. Although Europe is not the worst continent, I would say, for sure, it's quite complicated for them to gather the data and to deliver the data. Is there a way for European community to really to support that or to push the different national institutions to really participate to this? It's not only an ambition; it should be also concrete.
Yeah, thank you very much. I think this is very interesting question, and of course this is also challenging and difficult also question, as also you mentioned. But yes, there are also efforts, to trying also to connect also this with different also international activities, and trying also to push, let's say, also at the international level. For instance, as you know, we have also supporting what we call this GEO, the Group of Earth Observation, which has also this international also dimension, trying also to bring also all the key players at the globe, and trying also to ensure also the linkages with international activities. I'm sure that also Copernicus is also establishing also context. So there are also trying of the initiatives, under the EU, the UN Water Conference. There have been what we call, voluntary commitments. So member states, international organizations have also committed also to make different actions, and several of these actions through the international organization, for instance, WMO. Also, there are also data-driven, trying also to support this globally sharing also of data. And we are also analyzing and trying also to build this international dimension, especially, for instance, with Water for All. And this is, for instance, a concrete example. This data sharing, strategy that Water for All is intending has also the link also to link with ongoing also international activities. As you have seen, one also of the let's say ambition of the Water for All is to strengthen this international water cooperation for research and innovation in the water. And this is a concrete element. So Water for All, this is an important, because Water for All bring together also national funding mechanisms. So organizations in charge of, structuring also water policy. So this is also a very good way also to link international activities at the European level, at national level, also with global other activities. But of course, this is not an easy task because there are, organizations, they have also their policies, they all want to lead and to have, a leading role. And but there are, progress little by little in this context.
Thank you, sir. Is there any question? Yes, Joël Donde from Magellum, Toulouse.
Thank you. Just two points maybe of observation. Yeah, you mentioned a lot of initiative, which is very good in terms of dissemination to the users, to the applications and so on, and the portals, for example. This is, of course, fully needed, but we should also maybe try to highlight also the need for improving the algorithms and yes, building the data for feeding all these systems, and we shouldn't forget that. So, in fact, I know that a lot of research institutes in Europe are involved in that, and the space agencies too. But I think this is really needed in this sector to trying to continue to improve this kind of yes, building the data before disseminating them. And the second point, I think it is another important point in my view, is to, of course, disseminate the data, sharing the data with the users, trying to develop the applications and so on, which is one very good objective. But we also need in Europe a strong integration of what is in the back end, in fact, building the systems, building this integration of all the variables, building operational systems and so on, which is not easy, and it requires a lot of effort. Just an observation. I don't know if you have any comments on that. Thank you.
No, thank you very much. I think this is, I take note. This is something that, of course, we don't also forget. We continue, you know, as you have seen in different also projects, we continue also to give this this focus. And this is also is very important. I think we should also take these opportunities. Very often, we know we have also what we call, you know, coordination support action. This is actions that they can bring together, also try to consolidate also funding also in particular issues. And this is, I think, this is an area where we can also all together try also to see how to find, you know, the best way mechanisms also to bring also the different also communities, because there are different activities going on, and how also to better also to consolidate. This is something which, of course, we need also to pay attention. Thank you.
Any other burning question for the European Commission? I'd like to say that we are trying to coordinate everything we do with the European Commission, and there's a coordination agreement at high level, launching flagship actions. And there's a beautiful complementary with the, you know, the technical agency that we are, with exploiting, I don't know, building, launching, exploiting, operating, but also exploiting the data coming from the satellites. And the European Commission complements very well this development of the, let's say, what we could call the ground infrastructure, including cloud computing, digital infrastructure, but also algorithm development and the support of in situ data, which we always at the European Space Agency call for in situ data as something that we need in order to do our business. And also the modeling part, the assimilation modeling, and meaning forecasting, which I think is very important to forecast what's going to happen next week or even next century. So we are organized with these coordinated calls, and I think you should benefit from that. When you see a call from ESA, you might see something similar from the European Commission, and I would encourage you to apply to both and see that you can do this federation of resources, like we like to say, and repeat and repeat. The results are should be bigger than the sum of the parts. If there's no other question, I would like to thank you, Panos.
Thank you very much.
And we will now enter into a little wrap-up phase with very short, of course, too short, and certainly not covering what I mean, what the items that will end up in the summary and recommendation report that we are going to write all together, thanks to your input and the effort of the co-chairs, which I thank again here. And so we're going to go through themes. Something that I wanted to mention orally. Some people have told me, but you know, this workshop is a bit complicated because we have these sessions, and you know, there's pepper, salt, and pepperoni, and everything is put together, and so the organizing committee decided to work by themes, meaning in a theme we have a generic title. And then people submitted abstracts, and we took the abstract. We moved a little bit some abstracts, but we have these abstracts. And so there might be a session with snow and rain, then storage, drought, and so. So our intention was not to create some confusion and have sessions that have no red wire, but rather to break silos. And so now we're going to report on these themes, and the co-chair said, well, it's pretty difficult because, you know, this guy is talking about this variable, snow, the other one about precipitation, and this one about storage. Yeah, but there's the H2O that should do the link. And so we'd like to break the silos. We might end up, for the recommendation, to invert the matrix and boil back to topics instead of themes. So now the very acrobatic task of one of the victims of the 42 co-chairs for the 5 themes and 14 co-chairs for theme 1, 2 per session block, is to just tell us what is the most silent bullets among all the dense feedback that we got during the discussion. And the victim is Marco Restano from Rome. My right and left arm in the business that we've been doing together for a long time. And thank you very much, Marco. 10
Okay,
minutes.
thanks, Jerome. So I'm giving this summary on behalf of all my co-chairs colleagues here. Session 1 was quite dense, included I think 7 sessions devoted to the advances in remote sensing methods, techniques, and products. So the first session was chaired by Angelica Tarpanelli and Karina Nielsen. Recommendations are the following. We need to involve the commercial sector data to complement the publicly available data from space agencies. We need to implement specific platform where data are stored and easily downloadable for small areas. EUMETSAT is working on this solution for Sentinel-6. We need to bring in the science community the paying stakeholders and a new space industry. We need to continue investing in the NADIESA altimeter, so Sentinel-3, Sentinel-6, and also Cryosat-2, I would say. We still need to have reliable dynamic water masks. The importance of the center line of the river and identification of lakes in the Arctic was also underlined. For river discharge, it is important to estimate the cross-section bathymetry. And this could be probably also done from satellite, but it's still an open point. The other session, 1.3, we have no contribution, unfortunately, from session 1.2. The session 1.3 was chaired by Fernando Yamarillo and Fabrice Papa. Science recommendations and also recommendations for society users. For the science recommendation, we should better identify which water resources have the biggest knowledge gaps, wetland, groundwater, ice, and also others. We should work closely with the climate and ocean communities so that they use our satellite-derived hydro data and increase dialogue with other communities towards interdisciplinary work. We should better quantify uncertainties and reduce them so that they can be used in operational context and define which is the optimal latency for real-time or near real-time data to be useful. Recommendations for society and users were the following. We should understand if the use of remote sensing hydrogeodetic technology is constrained by know-how, improve the dialogue to involve stakeholders and end users during early stage of research for a real co-construction. We should make sure to tackle the lack of funds for research in the Global South and understand where there is a need to better understand, quantify, and forecast water resources. Session 1.4, chaired by Nuno Moreira and Luca Ciabatta. Recommendations are the following. So use of additional monitoring re-engages networks besides the official ones. Quality issues possible. More use cases could help in the assessment of operational satellite precipitation rainfall products. Precipitation was only slightly covered during the workshop, despite the strong link with the hydrological cycle. So maybe a dedicated workshop could help in finding additional recommendations. Session 5 was chaired by Diego Miralles and Jacopo Dari. Indicated that we need for more thermal observation at field scale, perspectives on the integration of satellite-based bathymetry information into operational warning system. We need to continue support to in-situ networks and also collocate land hydrology and atmospheric observation. The last two sessions were devoted to altimetry, especially session 1.6 chaired by Nicolas Picot and Jean-François Créteau was, let's say, fully focused on SWOT. And these are the recommendations. So SWOT capacity have been demonstrated together with the current nadir constellation. 11 nadir altimeters are flying at the moment. The number of observations are large, but we need to they need to be complemented by observation at high frequency, like so-called SMASH concept in the past. We need to involve the commercial sector data to complement the publicly available data from Space Agency, but those newcomers should work in close cooperation with scientists and agencies. Merging of SWOT and nadir altimetry, Sentinel-1 and Sentinel-2 images shall be supported. There is a large room for improvement on current L3 products and nadir processing data. Continuous support also to existing in-situ network is recommended. The last section is the one I shared with Jiaming Chen. Also, this one was focused on altimeters. Recommendations are the following. Future research activities shall maximize the synergy between SWOT and unfocused and fully focused SAR data. Fully focused SAR processing shall be better investigated to possibly agree on a single post-integrate and tracking strategy in view of future thematic products. Unfocused SAR at 8 years should be considered to develop future thematic inland water products. Platforms like the ESA Altimetry Virtual Lab critically support the research activities by providing innovative thematic products and powerful virtual machines. Alternative empirical trackers, like for instance DTU and WOP, should be considered to deal with multi-peak waveforms and evaluated against OCOG. And WOP can also manage the transition from estuary to the inland water. We shall continue investing on artificial intelligence for waveform classification, data analysis, processing, and data recovery. The benefit of the usage of drones and idle microstation has been acknowledged, and as well as the validation framework established over French rivers with more than 3,000 stations. A training day on orbiting and in-situ sensors and data, processing strategies, modeling, etc. should be planned for students and early career scientists in the next editions of Hydrospace. And that's all.
Any other participant in these sessions or co-chair want to add something? Pretty dense already. I have just a small announcement. Who's doing the wrap-up for session 4? No, I will talk to you just to show you an email I got. A question.
Can I
Yes.
have add something? Yeah.
Can you just present yourself?
Yeah, I'm Malik from Hydro Matters, and I just want to talk about a specific topic. We didn't talk a lot about the OLTC.
The OLTC?
Yeah. And but I think it's important to say that we can improve in the next mission. It would be interesting if we use the uncompressed OLTC for the every next mission plane with an nadir OLTC, as it's the case for Sentinel-6.
Okay.
And also, if we can combine with the benefits of the OLTC bit mode of JSON3 and SWOT, which can switch between the two functioning mode. It would be great if we can combine the best of the two missions.
Okay, thanks. We'll insert this recommendation, this point in the final report. Thanks.
Thanks a lot.
Yeah, this is a very important point. In the past, I've been fighting against the old TC, and the CNES people were getting mad at me and so on. But it's a beautiful mode. But I always said, why do we have only 1 megabyte for covering the whole planet with instructions on how to open the window of the satellite? Because memory is extremely costly when it's hardened for space and so on. So the idea is that we would like to use OLTC because we're sure to get the target, but we would like to use OLTC everywhere as much as possible. So there's been a big improvement. And now you have the possibility for your favorite target, your favorite reservoir, your swimming pool, like you set it out of the window so they don't measure the level. Because now we have a swimming pool mode, you've understood from this week. So I encourage everyone to go to the website and to prescribe their favorite targets: small rivers, lakes, reservoirs, and so on. Because if it's not prescribed, it will stay at the previous instruction, and then it will go over hills, and then it'll go back to the next instruction, which may be the space between 2 tributaries. So thank you very much for having made this comment. One more question, Cédric David from JPL Caltech.
Marco, thanks so much for the summary. A couple items that I recall from conversations, and you might have mentioned them, but maybe I missed them this Friday. One of them was ensuring that so I think the community was interested in having both the high spatial coverage of a wide swath and the high temporal coverage of something together flying at the same time, and that co-measurement, I think, is something that was of interest. And somebody also mentioned the interest in observing water velocity, since it's in the topic of advances in remote sensing, I thought that was relevant.
Thanks. Yeah, let's say that we didn't have too much time to discuss among ourselves to agree on everything, but I fully agree. And in the last slide, I reported a point about the drones and the microwave. So this presentation given in one of the last days was, of course, of cardinal importance, and the flow velocity is a parameter for the estimation of discharge with combining also other satellite measurements or near infrared, very important. And so probably we look forward to have systems improved in this sense by evaluating also overflow velocity to improve this capability. Regarding the first point, of course, I agree, and we will also include these recommendations. But as you know, we are recording all the meetings, so all the session will be reviewed, the discussion will be reviewed to provide a way detailed report on what you said that will help all of us, I think, in shaping the future activities. Thanks for your point.
Okay. Thank you very much, Marco. So for session 2, we have Pierre-Olivier Malater from Montpellier. Lucky guy, because he's going to be on site for the 30 years of progress in radar altimetry.
Yeah, thank you, Jérôme. So I am the victim for topic number 2. Not because I have the most knowledge on this topic, but because I don't run as fast as the other chairman. We are 4 in the room. There is Simon, there is Rajat and Adrien, and I think the other one already left. So we made a summary. So we had 4 sessions with about 5 papers, 5 presentations. So it's about 20 presentations covering different topics, different water objects. So we had snow, a few presentations on snow, some on ice cover, a lot on surface water, using hydrological or hydraulic model, and some on more global models, also dealing with evapotranspiration, soil moisture, and vegetation and irrigation. So we made, and I give a big tribute to Simon, who made most of the slides for this presentation. Okay. Yeah. So we are not presenting the seed questions of the 4 sessions. So it's more a summary of what we had in mind that raised the question that were during these 20 presentations. So they are split into different groups. The first group is about data set for land surface and hydrological or hydraulics models. So first suggestion was to improve the data set, first for model parameterization. So for example, water mass for river width, sound coverage, soil texture. Second point, to improve model forcing data set, so that can be used as an input to the models. Yeah, and of course, all the presentations of this group were using some models at some stage. So it could be either data-driven models or physically based model. Sometimes some were using some artificial intelligence, and it was at different scales. Some were very local ones, or at the water basin scale, or regional one, and some global ones. Third point was to improve the validation data set, for example, including evaporation, transpiration, to enhance the legacy benchmark hydrological data set for model validation and intercomparison. So for example, but not only discharge in space and time. Another point, we have more and more data, and it's sometimes tricky to get the interesting information we want to use. And now we have some common reference that were developed in the context of the SWOT mission, like the SWOT database or the PLD database. So, okay, maybe it would be interesting to, when possible, to map the data set onto these references, but it's tricky because also these references should be maintained and scalable. Also, a point was raised sometimes about the uncertainties. We had some discussion about this issue of the data set and how we communicate with them. So it was the first group about this data set. Second group of questions was about sampling and resolution, both in space and time. So first one, to continue increasing the spatial and temporal resolution for better insight into hydrological processes. Second one, and we had some presentation on that, coupling hydrological and hydraulics models, or a combination to better propagate observations sparse in space and time. Also, it was a point. Yeah, we got a list of the seed questions of the last Hydrospace conference 2 years ago, and of course, these points were already raised in this list of questions, and this one was definitely inside. And then it was also presented before to improve the temporal resolution, for example, with the SMASH mission, and also the spatial coverage with swath altimetry. But also for the first slide, with these 2 points. Other topic is the integrated water cycle view. Continue developing techniques toward the better closure of the water balance. Use various components of the water cycle to better constrain single component estimation. Also, some discussion were also raised talking about energy and carbon cycles to better constrain the water cycle. Promote a water cycle ECV. Then another group of questions about climate perspectives. Since we can reach, we will have the 30 years of altimetry soon, so 30 years becomes sort of length of time series that can start to be used for also climate change and global change analysis. Continue also in order to have this long-term data set to continue developing retracking methods for the past nature altimetry missions. And then 3 more points. In situ observation are still necessary. So for example, river discharge, not only, but this point is certainly important. Also improve knowledge of anthropogenic impact on water use, like irrigation, hydropower plants, dams, management of dams, etc. And then also some discussion also about the new techniques like artificial intelligence, machine learning, and citizen science. Okay, so I think it's at least a summary that we had in mind. If I am missing something, the other co-chair, you can say what you have in mind, or we can go to some questions or remarks.
Thank you very much, Pierre-Olivier. I have a remark, in fact, which is also concerning the first presentation. We have a kind of demand of most of the time of a new mission, new technology. We also push for high temporal resolution in the future, which is indeed very important. But we also have what you mentioned here and what was mentioned also, the need for past mission reprocessing data with new development, for example, in road tracking or the full focus for the SAR, etc. Do you think, and at least I think, that it should be something we really push towards the agency, because it means all of this, it's interesting, but it means money also too, because it's not easy task, it's take times. We just have, for example, recently the reprocessing of the top exposed hidden data more than something like 20 years after the end of the lifetime of the satellite. So it means, do you think we really, as a community, need to push strongly the agencies to help to have that, and that it's not only a good wish?
Yeah, I think so. I mean, whatever approach methodology we use, data-driven or model-based, physically based models, we need data and in long-term series and with a known quality of this data. So without entering into the details here, for me the answer is yes, and I think everybody will agree on that. Definitely, yeah.
So you believe, or you think that it should be one of the recommendation from this conference to really push having this new retracking algorithm, etc. Well, at least for the past mission reprocessing.
Yeah, of course, yeah. For example, when I was working on the Congo River, so I was using the recent data using JSON and Sentinel, but also you see past data and yeah, it's very useful if you can use them and if you know the quality and if you have this retracking method on that and you can use this data, and yeah, definitely I think it's important for all the modelers.
I can just add something about that. Yes, I think it's critical to have this recommendation. And beside being able to process long-term time series, we have to understand what the uncertainties that are underlying. Because what you want to do is to merge and to bridge the gap between in situ, past in situ data. You have a lot all over the world for, like, let's say the 20th century, but we don't know what the uncertainty that are inside this data and what are the ones that are inside the oldest altimetric mission. I think for altimetry, the example is really clear. We have, you said it, 30 years of data that can help bridging the gap between the present and the past. But for now, we cannot do it. And we need, I think, clear recommendation to improve our methods and to continue on research to produce these long-term time series. At the same time that, for example, ESA continues funding new and innovative missions.
Yeah, I agree.
Yeah, very good point. Yeah, we have the climate change initiative to try to stitch together all this long data set from different missions. And it's part of the objective just to work on the intermission bias and the drift. So it's, yeah, thank you for underlying this point. Adrien Paris.
So Jerome, just picking up on what you mentioned, I think it's important not just processing of the previous data sets, but also develop continuity missions so we can really understand the impact of climate change on how the water cycle is, getting impacted. Is it accelerating? Is it really changing our different locations? What is the impact of climate change on droughts in certain areas, on hotspots, floods? Unless we have long-term consistent data sets, we will not be able to address those questions.
Okay.
Yeah, maybe I can add in the paper that was done 2 years ago. Also, the last recommendation was a sort, because we have a lot of different approaches. So depending on the expertise of people doing that, I mean, if we select a methodology, it's because we have some good reason to do that. But one question that was raised, I think it's a very good point, is is to better understand among the different portfolio of methods we have, which one, depending on the given problematic and application, which one to select. And I remember during the first days, there was somebody saying that, it was a quote, saying that there is no better model, but there are some useful models. So then depending on the problematic you have, then it's also a cost-benefit evaluation. So we have this sort of portfolio. I think we had very different type of methodology presented, and certainly not is better as the other one or in general, but it depends on what problem and what people will use this. And so also I think it's a important question that also we have to address to improve in this direction.
Okay. Yes, thank you very much for this additional comment. And it comes to my mind to say that, for instance, in the climate change initiative, we end up with different options, and we do a round robin to see which is the most performant. So I don't know, useful, accurate, stable in time, and so on. And we end up, then we seek consensus. So we organize a review of international experts coming from all over the world to look at what the round robin exercise produced, and try to develop a standard that we will apply, and we will apply in the future. So we have, let's say, a very consistent suite of data, either from over different regions or from mission to mission. One more comment?
Yes, one more. So Mark Schröder from Deutscher Wetterdienst from DWD. So the CCI program was mentioned, and there will be a follow-up, the climate space program. I'm involved in the EUMETSAT-SAF network, so working on CM-SAF. So there are other European initiatives on climate data records, and there's quite some experience on going backward in time and work with heritage data. And I think it would make a lot of sense to join forces so that the combination of both, or whatever is available, is getting larger. And maybe a side aspect of this, to be more specific, is there are all these new great capacities with the new sensors. And it will be a challenge to find means to bring this enhanced capacity backward in time. And I think that's something that can also benefit from more attention.
Absolutely, and something I've been advocating when we have a mission that sees a scene, can we extract this information and use it as a priori information for the previous missions where it was a bit out of focus, or a bit more difficult, less resolution, or less more noise, and so on. And indeed, and we talked about that. We said, can SWOT help Topex Poseidon? Now that we see it, can fully focus SAR, now that we have a much better vision of the scene, including a swimming pool, biggest swimming pool in the world. Then can that help the retracking of satellites, which are a bit, let's say, cyclopean, you know, just one eye and one big antenna, one big field of view, and that is a very good point. And of course, it gives idea to researchers to develop algorithms to apply. And including modern in-fashion things like artificial intelligence, artificial statistics. Okay, so we should move on to the next theme. Thank you very much. And so who's the victim for the next theme? I didn't pick that up. So the theme number 3, advances of science. We have Karim Douche from ESRIN, the lucky fellow working with us for a couple of years. Thanks, Karim, for taking up the duty.
You're very welcome. So yeah, thank you. I will present the conclusion of the discussion we hold in the Advances in Science and Process Understanding session. This session was chaired by Benjamin Kitombo and myself for the first block of presentation, and Cynthia Bonadan and Sofia Armida for the second block of presentation. So this session actually was relatively small. It consisted of 9 oral presentations and 5 posters. And so here I should confess this is my own comment, so I take full responsibility for this. That's maybe there were not enough incentive to focus more on process understanding. Of course, as you mentioned, evil is in the details, so probably a lot of presentations that were in other sessions could have perfectly fit in our session. But yeah, that's just to fit the discussion, let's say. And that's also my take on this, that maybe it will be interesting, relevant to invite more hydrologists with really no Earth observation background for this. Okay, the topic that were presented were of course very interesting, very various. So we talk about dynamic of water storage during hydrological extremes or groundwater discharge, total drainable water storage, natural and anthropogenic variability of different hydrologic quantities, high resolution monitoring of irrigation, quantification and attribution, so cause effect of hydrological phenomena, and also compound extreme events. And this around many places, so from California, Congo, Europe, Iran, United States, and even globally. So I encourage you to have a look at least the slide of this presentation if they are made available. I guess that's a plan. Okay, so some general remarks. So as I say, it was quite a small session, so I may have less recommendation and remarks than the previous in the previous presentation. So maybe the first one is water storage, in particular groundwater evolution is becoming an important topic. So I won't come back to how critical it is, of course, for water management and climate change. So of course, here GRACE, GRACE-1, GRACE-C, and in the future, we hope all MAGIC are much needed. With a particular maybe emphasize on the fact that the quantity that's measured by the satellite need to be downscaled for many applications, and that's so maybe some effort should be directed on this topic. I cannot stress enough, as my colleagues before, that in situ data, river discharge, but also soil moisture, piezometric height, water extraction, and so on, are essential to make further progress. So we still need to maintain this in situ infrastructure, gauges, and so on. And yeah, in general, of course, we still need to work on better physical process representation. Another point that was raised mostly in the second block was that artificial intelligence, machine learning in general are still underexplored in hydrology. And that's actually, and I can really picture myself in this description, that most scientists do not have the knowledge to leverage the potential offered by AI and machine learning. So probably more collaboration are needed between the scientific community and also computer science community to get some help and get quickly to the state of the art in terms of modeling with these incredible tools. And as a consequence, maybe an idea will be to dedicate more funding to support the introduction of computer science in this research activities. Need for good quality data to model training, that's, I think, obvious, but still need to be said. As I say before, more in-situ data are required. That's, I mean, we can not stress it enough. So need to maintain current in-situ observation infrastructure, and if possible, that was also already mentioned, to promote the release and free access to data from national water authorities. That will be also essential, and probably also to to have them easily accessible. A framework, of course, that's a bit trendy, but may be really useful to gather observation and process understanding is working towards integration of in situ EO data into digital twins. Last point, which is also maybe a framework to focus more on process understanding, is also to implement more research projects dedicated to specific region and not to a specific process. So, for instance, working on the Congo, which have been shown, I think, in many presentations, to have to rise less interest than, for instance, the Amazon. But that's also a challenge and very interesting topic then to explore. Congo or other region, of course. And that was my last point. So thank you. Obrigado.
Thank you, Karim. Indeed, there's very interesting points. Promote the release of free access to data from National Water Authority. WMO has been, let's say, very active since its inception. I don't know if it was World War I or later. You'll tell me, but basically the idea is to release the data, especially that it can be used for scientists. But the global data, the global runoff data center, we've seen that plot everywhere. It's decreasing, it's decreasing, it's decreasing. And it's not just for lack of maintenance of the gauge. It's also because water is a proxy for power, one way or another, either agricultural or energy. And so let's say these walls have to be taken down as much as possible, especially for science. And so we are dealing with satellites. We don't see the boundary between the countries. And I think space is a very good tool to remove the difficulties in transboundary basins. And what can we say? We have to, it's more political than technical, I believe. And yeah, it is technical because in some places you have to maintain the gauges. But it's a good point to understand, and we should maybe promote it in the sense of for scientific use. And maybe if we don't get the real-time data, we could get the historical data. When the government of a country is no longer in power, maybe we can release the data. It's a suggestion. Yes, okay, we invite more hydrologists with no EO background. We didn't invite anybody. They all came by themselves, you see. In fact, when we launched let's say the description, the objectives and the themes of the workshop, and even on the front page of the website, it says that this is a workshop for in situ people, modelers and so on, so they can meet space people and vice versa. It's called Hydrospace, yes, of course. So maybe it's a deterrent, we should call it Hydrospace, in situ, modeling, assimilation, and so on. But we have the same problem with the coastal altimetry workshop. It's not, I mean, we tried to. And the recommendation that we got in the coastal altimetry workshop is that each of us should go to meetings where there's no EO, no space EO. And in fact, I applied to make a speech in a French meeting in Lyon called IS Water or something like that. And my abstract was refused because it was not about water management and operational water management. It was about, the capability to observe and so on. And I was a bit disappointed, But next time I'll crash the party. Yeah. So let's say, I think it's important for each of us to also participate in meetings that deal with just modeling or just in situ and so on.
Yeah, that's exactly the point I wanted to stress. That is, I have little experience, so you might confirm or infirm what I say, but it gives me a bit impression that somehow they're building silos of one hydrology with Earth observation and another community doing hydrology almost without, in a different manner. I don't know how much this is true. This is probably my impression, my take on this.
Okay, so we'll try to solve the problem. And we could invite, and we say, spend a week in Lisbon, the European Commission will pay for your travel and your hotel, or ESA, or CNES, and then we get some prima donna to give a keynote. That's a very good remark. Any complimentary remark before we switch to the next theme? No? Thank you, Karim. The next theme, Federico? Francesco Aranti will be the victim for theme number 4.
All right, thank you. So we had a very interesting session on water science for society. I will go through the whole list now, but I think the 3 main takeaways that we got, we had long discussions related to how to engage, communicate, and work with stakeholders, and in general, people who work in society to address societal problems. And we had pretty much, I saw that this was also a theme for other presentations. We also had long discussions on how to evaluate and benchmark our data sets that we retrieve from satellites, and how to do that in a way that is relevant for decision makers and policymakers. And we also had quite long discussions on the resolution of the products that we have to deliver, between high resolution but local products and coarse resolution but synoptic products. These were more or less the 3 main themes that we had. Going more into the details, the session 4.1, early morning on Wednesday, we had a long discussion at the end, very vibrant, on the needs of stakeholders and how to support those needs. We came to the following conclusions: that sometimes when we look at warnings and alert systems, they use a traffic light system with colors, but we came to the conclusion that that is not enough sometimes, and so we should attach to that some quantitative information, especially when we talk with decision makers, people that have to make decisions regarding water management. Also, high resolution maps are needed and important to decide if and which action have to be taken locally, and that we look back to the coarse resolution part later. We also had a long discussion on the fact that, especially when we look at droughts, we have a variety of indices, hundreds of them. And so there is a need here, and the ESA can also help for that, to develop best practices that are shared across people, to make sure that we all use the same indices and we do that consistently. And obviously, at the end, it was mentioned that more collaboration, discussion, and information exchange between the scientific community and the groups of interest is essential and needed so that both groups can benefit. We come to the conclusion that we were quite a lot of scientists and remote sensors people in particular in that session talking about the needs of people outside our work, but we had a lack of those people in the room. And so that's where probably we have to improve a little bit. And the underlying recommendation here is to look for satellite data that have high spatial and temporal resolution, but also short latency. And latency is key when you have to make decisions. You can wait 1, 2, 3 days to make your decisions. We generally get questions that need a very quick answer. Then we had another session, 4.2, again, water science for society, which was the overarching theme. We had quite intense discussion here on evaluation and benchmarking of our products, particularly related to floods, but not only that. So we got the suggestion to look into the meteorological community, particularly the community working on rainfall products, for protocols used in validation and skill assessments there. It's also important to improve the trust in the flood products, particularly flood delineation, which should also include probability in flood mapping, if possible. As well as, this was also a theme that I saw in other presentation earlier, look into including the new space industry, even though some of them develop their own downstream products. So that might be difficult or tricky. But we see an opportunity there. The challenge is obviously we need to receive feedback from users requesting flood maps. We have to pay attention particularly to missing significant flooded areas, which is, we see that as the main risk. It's also important to address and evaluate the uncertainty in the forecast and try to reduce those if possible. And in general, there is a need to work on benchmarking data sets that are used for the same application by different people that sometimes don't really talk to each other. Related to that, we have a concrete example. As you may know, Somalia is experiencing dramatic floods of some of the main rivers of the country. We have more than 2 meters in the floodplains, and even in cities, higher than 1 meter. And we have a humanitarian response organizations that are overwhelmed. And what we currently have at the moment suggests that this is an event closer to 1 in 1,000-year event. And obviously what we see, and we encourage anybody to engage with that, is to mobilize our engineering knowledge to gather all possible data types quickly from all the potential missions to define science questions and challenges, show these organizations what data we can make available and how fast we can do that. And doing the above for this one event in a coordinated collaborative effort will tell the response organizations what the EO hydro community can achieve. So this was brought up in one of our presentations, and we thought it was good to iterate that. And finally, we have the last session. In this case, we also look at the importance of high-resolution data sets, particularly for snow coverage area detection, snow water equivalent, as well as irrigated areas. So we iterate the importance of those data sets. But we should also not forget that sometimes agencies are more interested in a synoptic view. So in viewing things across the board, I made the example of the Alpine region, which is large, and sometimes, especially for transnational rivers, they are not really interested in the specific snow-covered area or SWE of a specific slope, but really in how things are playing out across the board, across large regions. We also think that the satellite data offers the possibility to increase the transparency in policies definitions, and that's probably an opportunity that we have to leverage. We had a specific focus on the thermal infrared data sets, very useful information for improving evapotranspiration estimates, as well as irrigation. We saw quite a lot of work on irrigation going on right now, thanks to ESA, and that's a very major advance. Again, we iterate the importance of interacting with end users to increase the trust in the scientific products, as well as to improve the products to be really responsive to the needs. And then we got final recommendation by one of the people who presented through email, specifically related to safely managed drinking water services, and the importance that high-resolution imagery can play for that, because from those high-resolution imagery, we can capture roof materials and other housing characteristics, as well as additional information about height of buildings, which could be useful to develop human development indicators, which could then be used to distinguish higher from lower income settlements. Ideally, this data will be updated once a month, but already having once a year will be very helpful. So this is an example, a very specific need where Earth observation can be very useful. And with that,
thank you very much. It was very interesting. It's another aspect of the conference that is also very important. I'm pretty impressed by your exercise on the Somalia region, and probably it can be extended to many areas in East Africa, which suffers a lot from inundation recently. So it's a nice idea to show what Earth observation and people involved in Earth observation, both scientists and private companies can do. But do you have a plan for something concrete around that question? And can how to say for you, to your opinion, can the space agency endorse also support for that?
so I'm not the person who proposed that, and I don't know if the person who brought that is in the room right now, right? So probably you can comment more on that.
It wasn't me, it was Guy. All right, so blame him. But his, I think what motivated this particular exercise is Guy's strong belief that we need some kind of benchmarking system for understanding flooding. And I think that's something that he's been advocating for a while. And the Somalia flood is a perfect example of places where it could be applied. And that's about all I know, but I'm glad that it resonated with you guys.
If I can, do you? I just wanted to mention another example of that. There is quite a lot of materials that we saw in these sessions and also in other sessions related to snow and mountain regions in particular. I think that's another area where we will benefit, especially as user, from some intensive benchmarking. I know that some initiative at the ESA level are already going on that. What we see right now in the mountains is that they are warming up very quickly. Snow and glaciers are declining very quickly as well. In Europe, we experienced the implications of lacking snow in 2022, 2023 as well. And if I have to recommend another area of urgent applications, it's probably the mountain regions of the world, which provide the vast majority of water that we use. They are water factories in the end. And so what we see over there are several reasons to believe that they are in emergency conditions right now. And so that's probably another area where I think we need some additional effort.
Don't hesitate to walk up to the microphone.
Yeah, regarding warnings, I just think you mentioned already, it's the first line. I think we can add a little bit more on what was proposed in the discussion. Of course, we talked about the risk matrix concept, where you have the intensity and probability, which really, apart from the quantification that was also discussed in the session, that will give a more capability of managing the risk from the user perspective.
Right.
So in there, I think you can add that. That's something that from the meteorology, we are working on it already. Some people are using it, some countries are not still. But the European Commission with the Aristotle project, for instance, they are using the metrics that are produced by all the providers. So it's something that really can be already more referred. Regarding the 100 indexes concept, the problem of having too many, I think we really should try to move away from the holy grail, having one index explaining everything. It doesn't happen. It's not true. So these concepts of the dashboards, the scorecards, this is some things that exist. These concepts exist already. So they really should be kind of put in the line of work on how to work with this. Of course, you have to work to get to this. What is the best dashboard? What is the best scorecard? So it's a lot of work too, but it's the way to do it, because you don't have a single product to deal with this. I can give the example, for instance, right now, the EFAS for the flood monitoring. They have 3 products, and if 2 of them are giving a flooded area, then it's a flooded area. So it's they are using all the methods that they have. So that's really the way to go. Probabilistic. The more the merrier, because you have to make a cut and okay, these are not to be in the cluster, but then you decide which are the ones, and you should go for that. So I think it was a very good discussion. I liked a lot, and I think it's very important because we work for society. Right. Just yesterday we had this event of precipitation here. We just have one line from yellow to red. If we had the matrix, we would have clearly more ideas, because it was a severe event that could happen. The probability was low that it would happen in Lisbon, and it did. So we went to orange right over the situation. So the linear simple traffic light system, it's narrowing the possibilities. The metric is enlarging the possibilities. Of course, we have discussed that it depends on the user. So if it's an expert user, they know how to use it because they are all related. The cry wolf problem, it's more a problem for the unexpert people, so the people that are just using. So there is a difference on this thing. So I like the discussion a lot, and it was very fruitful. Thank you.
I appreciate yes, please get near the microphone. I appreciate it very much, and I thank the meteorology people from EPMA, Isabelle Trigo. I would like to say that the word latency here, I think, is important for meteorology, and we should put it in bold and see that it's also important if you want to do flood forecasting, for instance, and I'll talk about that in my closing remarks. And the example is we had a CRISAT workshop a long time ago, and CRISAT with an Earth Explorer to design an instrument and see if it could work. Latency was not at all part of the mission requirement, but after it was flying and very successful, there was this recommendation to get the data in near real time. And so the agency did a little effort to have a little Unix machine on the side of the ground segment, getting the data out by FTP to a bunch of happy few aficionados that needed that data to synchronize with campaigns in Antarctica and also in the Arctic. So yes, these kind of recommendations should be, we should put them forward, and we appreciate it. So Nick, Everard?
Okay, thank you. Yeah, just a comment on the sort of responsiveness thing and the unfolding crises in South Sudan and Somalia. Before Guy left, we discussed whether we could get a video and try to process it with our video method. And I'm pleased to say we did. We got the video, we requested it Tuesday, we got it Wednesday, we stabilized it yesterday. I've processed it here this morning. And I think so, for me, I think that's a fantastic illustration of how we can be responsive using new techniques. But with permission of the chairs, I wondered if I could show a 6-slide presentation on that, either now or after the break or during the break, if anyone is interested, just to show the workflow that we go through to get that.
Yeah, we'll see. The most important part is to get some feedback on the let's say the discussion thought and the recommendation. And one thing that I will probably say later on is that I think the next workshop we should have less presentations and more discussion time slot. Yeah, I'm sure if you set it up during the coffee break with Marco, if you can take a few minutes to illustrate what you just said. Anyway, we have all afternoon if we want to. Yes, Santa.
I was just wondering, maybe thoughts in the room. So we often see Sentinel-1 was obviously revolutionary for floods, right? I mean, this first time we have SAR data that's open. But what now happens, or sort of like a side effect of this democratization is that everybody with a Google account and Sentinel data access, which is really everybody, is making maps and putting them out as soon as a Sentinel covers such an event. And I wonder if this is not just noise that people have to filter through. By people, I mean very specifically decision makers in this context, because sure, if you're a PhD student somewhere who's made a map, no decision maker is going to trust your map to take a decision on it. So this map is very much for self-promotion. And let's be very clear here, it's not helping the people on ground. So I was wondering if there is a possibility that the space agencies could, so the data should not be closed, but can we say that please during this time, don't be randomly processing data and putting it on there with no confidence intervals, no idea of whether your map is right or wrong, simple Otsu threshold. Just, it's maybe not the best practice. Is there a way that we could as a community do something about this?
This is a very interesting topic, which probably would take a summit at the level of United Nations. So you're asking us to decide between democracy and fascism. Fascism is a word that means do it, okay? So what should we do? Limit the open access in case of crisis and so on. So, of course, there's this kind of discussion that take place when there is a, let's say, a military crisis, when some data could be dual use and so on. But it's an interesting thing. And I think the more it's open, the more noise there is. Maybe there is a way to get something out of the noise more than try to stop the circulation of source data that will be misprocessed and misinterpreted.
No, there is no need to stop the circulation of data, but it's possible to let's say, put out a statement in case of events, because the GFM is processing the data, so we know that there is an event. So we could, for instance, put out a statement that please refer to GFM data or whatever. That is one option. The second thing is, the noise doesn't help, because we had this discussion very strongly during the international the space and major disasters charter was discussed at LPS, in fact, and there they said that, look, the reason we don't put this data out, one of the reasons, of course there are other reasons, is because this kind of thing happens. So there is a direct contact between the acquiring agency and the agencies on ground which need the map, and they process the map according to their requirements and send them to the agency, not putting it up everywhere. It's put up later. And so I'm not saying there is an easy answer, but it's maybe something that we should critically reflect upon.
Well, my easy answer is that the more it's open, the more people discuss, the more people, I mean, that's science, and maybe, I mean, we cannot say we're going to turn off social networks so this information doesn't propagate. But it's a very interesting question. I think we could have spent a whole weekend on a special summit on, should we censor some information because it might damage? And I think it's just above the scope of this workshop, but maybe we have an answer here.
No, but a hint. That's our problem with meteorology and forecasting. We have, of course, data is free, it's democratic. So, of course, what we in the warning community, in Meteor Alarm, for instance, what we try to work on is the authoritative voice. So, of course, you will have information from everywhere. Everyone, here in Portugal, we do already. We don't have a strong private meteorology, but we have information coming from everywhere. Some people know about it, the ones that are providing. Some people do not know as much, and they are still providing information. So you have to do, and I think in every country that's more or less the same. So you really have to work on the authoritative voice, and of course, the entities, the authorities, they should know where to go. You should promote yourself enough, but of course they should know where to go to. So this is clearly a work to do together, and so but it's not a finished thing for sure. And I agree that there is a lot of discussion, but that's already our world in meteorology and forecasting, clearly. And there is you cannot shut down information nowadays, so it's impossible. So you have to work on the authoritative voice perspective.
Absolutely. I'm sure the decision-making people like civil protection and so on, they have their sources and they're not bothered by the noise. And I think it would also lead us to another summit over a weekend in Lisbon is education, capacity building for people to understand what they're looking at, if it comes from this source, that source. And yes, yeah, I guess this is comment I wanted to say. Now, Antara is continuing the ping pong on the subject, yes?
No, just the final thing on this is that we are trying at the Global Flood Partnership to build a set of guidelines on how to work during such an event. That's the first thing, and I really like this comment about the trust. It's important, and perhaps also outreach. So many times I find myself having to explain to people what the global flood monitoring system is. So maybe we should, work more on outreach. It is an operational service. It is working on open Sentinel data. It's working on 3 algorithms that have been tested in a variety of contexts. It provides probabilities. It does all of that. So I think we just need to make it better known that people know, okay, there is this information source. I can go there. It's more reliable.
Yeah, and it brings also the subject of the information going the other way, citizen science. And we tried to get some data to Bentiu, where there's a refugee camp, Médecins Sans Frontières, UN mission in South Sudan. And we told them with the output of our global model that we have running in Europe, that the water is going to go up in the next 2 days. And they did the citizen science. They said, sorry, but the water is going down in this very specific location. And South Sudan is very complicated in terms of water. And so the more people are trying to get information out, maybe we get some feedback from people say, well, no, I live here, this is my house, and I don't have water up to my knees, but up to my shoulders. Okay. Thank you very much. Thank you. We have to move on. If not, we won't be able to enjoy more discussion over coffee break. And the 5th session is, the victim is JT Rigger. And it's about the novel technologies and future missions.
Okay. Hi, everyone. So we had, I'll just start talking while we're fixing things here. So we had sessions yesterday and a late session into the evening last night. So it was a bit of a rush to get everything organized this morning for slides. So please be patient with me, and any of the co-chairs out there for these sessions, if you see me drowning up here, please feel free to jump in and save me, please. Thank you. Okay. But I'll do my best to represent. We had sessions yesterday on future missions, novel technologies, and the future of water cycle research, right? And I would like to thank the co-chairs, it's Ilias, and then we had a session after that with Francisco and Wolfgang, and then in the evening with Cloud and Antara. So thank you, co-chairs, for giving input. It's not working. Okay, we'll do it. So our USB is not working. We're just going to do it orally here. So bear with me. Oh, we do have some notes. Okay. So I'll talk about those 3 topics: future missions, novel technologies, and the future of water cycle research. And for us as scientists, I mean, honestly, what could be more exciting than thinking about the things that we can't observe right now, or that we can't do right now scientifically, and how to do those things in the future. This is something that I think would excite any of us as hydrologists who do remote sensing. So we had talks yesterday on future missions that started the day with the future gravity mission called, MAGIC, a future constellation, and ended the day with like GNSS, remote sensing, and some other techniques. So a wide swath of techniques. We had stuff that spanned the electromagnetic spectrum, from really low frequency waves to do, deep soil moisture, all the way to very high frequency stuff to do clouds near the Arctic. So some amazing range of topics in techniques, but not only, a recommendation, not only did we propose techniques, but we really considered the way to evaluate potential new missions. How do you measure the value of information that will come from a proposed mission? This is really a critical question, because all these funding agencies, no matter who they are, have a limited budget. You cannot fund every concept or every idea that comes out. So really having evaluation systems to evaluate the potential information that might come from these techniques is the most important thing. And we saw a lot of talks that proposed different ways to do this. So a recommendation could be having some coherence in the community or best practices for calculating, estimating the value of information from new missions. That's something we could do. Certain missions are designed with objectives in mind, and that's clear from the beginning. But other missions, you know, it's a technological push or something that's moving that mission forward, and then really evaluating the scientific capability of that mission is the most important thing. We had talks about novel technologies that included things like machine learning and artificial intelligence, and other things, even like airborne or GNSS. You know, really the future of not only things in the air or in space, but also on the ground. What are we doing to receive this data? How do we mix it in with other data sets that exist? How do we incorporate it with models through data assimilation, machine learning, and artificial intelligence? And then on the recommendation side, we had a very interesting talk by Wolfgang, you know, that was a bit more critical of artificial intelligence and just using it without boundaries or without filtering. This can be very dangerous, right? So we really need to understand what we're doing when we use machine learning and artificial intelligence techniques and make sure that the results that we're predicting with these techniques are actually of value, are actually accurate, and actually contribute something positive, not just nonsense. And then finally, and I'm going to be speaking way out of my area of expertise here, on the future of water cycle research, we actually had some discussions on funding mechanisms and infrastructure around future missions. And so how do future missions get selected? That's kind of one question. But also, apparently, and anyone you know, on the European side, please help me out here. It's not my area of expertise. That when we have cycled missions that are launched for operational purposes, things like Sentinel series, that sometimes a new satellite will be launched while a previous satellite is still in space and may be decommissioned. But really, there may be opportunities to leave older satellites on so that we as scientists continue to get that old data as well as the new data, which of course we as scientists would like to always enhance and grow the amount of data that's coming in for our models, for our evaluation, for statistical analysis, for all of our research. So some questions about how missions are continued. If they're still in space, can we have a little bit of funding to keep that data rolling back in, even though it's technically the end of the mission life cycle? Is that something worth discussing or requesting as a community? It could be something like that would be worth mentioning in a report like we're going to do here. Second of all, the funding mechanism, and again, this is really not my area of expertise, the funding mechanism for science teams on the European side, how certain missions are launched. Like at NASA, we kind of have a mission is launched, and then there's a guaranteed science team for that mission. So a chunk of the budget for that mission is cut out, and that will be for science. And that's guaranteed every mission for 3 years, and then it's recompeted 3 years later and recompeted 3 years later. The same infrastructural system may not exist, as I understand it here. And so maybe some discussion around, are there requests from the community in terms of how we structure those funding mechanisms for earth sciences from space? And I'll pretty much stop with that, but if there's any questions or comments on any of those ideas, please, anyone feel free. And I'm pretty much just echoing things that I heard from our group. So if I missed anything, please, yeah, go ahead. Plug, yeah.
Claude will add.
It's not working. Let's try. Go ahead.
Okay.
This one works.
The question that you just mentioned and we discussed yesterday, when you take one out, when it is decommissioned, and you have to see what's the pros and cons. So what are we missing? I think for the discussion of this morning, I think we are really thinking, okay, do we go to spatial resolution, increase of spatial temporal resolution? Do we have the past and keep things going so it can work? I think there are different needs, clearly, depending on who's sitting here. I'm an operational guy, so for me, if I lose, and if we're complaining of not having temporal resolution as we would like, yes, and we see a satellite there that's just staying, it's something that it's very difficult to understand for me, of course. But of course, maybe this is not for ESA to respond, because it's an operational, more not to the scientific side and to the research side, more to the operational. So maybe this is, of course, a broader question, and we have to know who's paying what, right? But that's the broad question. But I think it should be really discussed. And Isabel was saying this, that we have to know everything to get to the final conclusion. But, so clearly all the stakeholders, the operational ones, the research ones, they have to be, well, present to really put things in discussion. Because for me, having this information, kind of, I know that I don't have quite enough microwave sounders to tune the precipitation in all slots of 3-hour slots. So we seen this yesterday or the day before. So are we removing things when they are not there? They are still there. So it's clearly one thing to discuss.
Can
you want to?
Yeah, just say something quickly. We discussed this a bit as well, that, you know, in the operational community, when there's a new satellite that's built, and then there's infrastructure that's built around that data set coming in, that continuity is a really important topic, right? And what's the reason to build a new satellite? Either you're going to get higher resolution, spatial resolution, temporal resolution, or on the science side, maybe you're going to observe something you never observed before, and that's exciting too. But there's, you know, a favoring there of operational, when the system's already set up, we want to keep the data flowing in, and if it's higher resolution, maybe that's even better, versus the scientific thing, which is, oh, well, we're observing something we never observed before, you know, G-band precipitation, right? That this is really exciting as well. So there's those trade-offs, but I think as a community, right, that we would represent, all right, it's our voice that actually probably contributes to that decision process, and saying, you know, how do you prioritize these different new concepts or new missions in terms of what the eventual payoff would be? But I think you said it well.
Yeah, still on the same topic. There's a third way why we get rid of satellites. It's because a new one has already been built and is there to replace an old one, and it gets launched. And then what you do with the old one? This is a point that Sentinel-3A will soon be facing. Now, I have to add that Sentinel-6C, which is to replace Sentinel-3A, is delayed because we don't have the right launcher. But the current baseline is between ESA and EUMETSAT that it might be switched off Sentinel-3A. Of course, the continuity is secured because there will be a Sentinel-3C taking over. But of course, in the whole scope of increasing spatial and temporal sampling, you might want to keep that satellite alive. And this is somewhere where you as a community would certainly could come up with a recommendation here, and even more widely in other gremia that will be discussing what to do with Sentinel-3A. You might not get everything. You might not get optical on both 3A and 3C at the same time, because it's a lot of download, but altimetry that already has been seen and this week has been very useful. So please speak out. Mention Sentinel-3A's demise. Bring the point about spatial and temporal sampling, and I am sure that ESA and EUMETSAT together will try as best to keep that satellite operating for this community, but also for the ocean community.
Yeah.
Thank you.
Yeah. Okay. I think we understand, you know, and there's maybe a small distinction between an operational system like Copernicus and the Explorer system, where we design, we launch a mission to say you have 3 years to demonstrate that this instrument is going to be useful in the future. And after 3 years, you've demonstrated, so turn it off and don't bother us with all this data flow and so on. And in fact, what Remco just said is that this is the most important part. For Cryosat, we have to ask for money to operate Cryosat, but Cryosat has already reached its mission objective, so you can turn it off. It's called euthanasia for satellites. And some people don't like this because it's a waste. It's a waste of everything. It's a waste of raw material that has been mined in order to build the object, you know. And so so we beg the community to come up and say, this is why I need more data from Cryosat and so on. And I think just saying, I just want more is not enough. I mean, the member states of ESA, they say, can you do a new application if we give you 2 more years of Cryosat? So is there a new application? So you have to be creative and say, yes, with that kind of data, you can do that. And so we count on basically the users. There's a use for these satellites. So let's spend the money and not spend it on something else. Like JT said earlier, we have new ideas. We want to build new instruments, new satellites, and we have to not spend the money by maintaining old satellites and operating. Okay, so there's a decision-making process and there's some lobbying to do. Claude, you wanted to add some more?
Yeah, just a few points from our presentation, the last session yesterday afternoon. Some during the discussion some recommendations that came up. The topics that were covered in our session or related to GNSS. A couple of talks on GNSS. One was involve the aspects of digital twin, and then we had also a presentation on drone and the use of that to measure water height as one of the variables. And so some of the points of discussion we had and some recommendation was to investigate the use of GNSS for monitoring of small rivers. When we say small rivers, the discussion was around how small of a river can you detect using GNSS. We know that from altimetry, if you have fully focused SAR and so on, we can reach pretty very narrow rivers. But what about GNSS? Is it 500 meters? Is it 1 kilometer? So that was a question, but there's need to investigate that the sensitivity of the signal to the presence of smaller water bodies. There is also, of course, GNSS, especially in the context of Hydro-GNSS, which will be a future mission launch at the end of next year. There's some products that are planned already, but there are opportunities as well for different types of products that are not as seen as the primary ones. And so the forest disturbances, whether some of the data that would be derived can be used for assimilation and weather forecasting models, hydrological models. Input into permafrost models, one of the product will be a freeze-thaw product in permafrost regions, but whether some of that information could also be used as an input into permafrost models. Inland water bodies, looking at open water and ice conditions, as well as river height. And then secondary products as well, ice concentrations on the oceans. But that could also apply to, I'll put my own spin here on lakes as well. We know that, for example, weather forecasting agencies in Canada is using ice fraction derived from sat observations as input into weather forecasting models. But one of the presentations showed there was sensitivity of the GNSS signals, the L-band signal to ice fraction on northern water bodies. So that could be used as one of the data sources to produce ice fraction maps on large northern lakes. There was also the topic that was part of some of our seed questions. There was a business discussion regarding gap filling. There is a need for gap filling. This is a requirement that comes from GCOS. I think there's CMOG, which is as recommended that they would like to have, as an example, being involved in the lakes project of Lake CCI, lake surface water temperature and lake ice cover to be gap filled. When we say gap filled is of course to replace cloud cover by either open water or ice or temperature values to replace the cloud cover. So that's a requirement that comes, but that's also, we've had the discussion about, and that was a point made by, I forget your name, in front, there was about more atmospheric fields regarding gap fill data. And I think you were mentioning commercial flights, and that's right? And okay. And that was a good source for atmospheric data, was it to gap fill, but that during COVID, the availability of data became quite small. So that's another topic that was perhaps taking advantage of commercial flights in certain cases to gap fill some of the data. And then there was also the need to support the CalVal activities in the cold regions and also improve the networks in the global south, and also to test and improve in the presentation on drone technology. There was a demonstration of the application of it over sea ice. I'm not sure whether the sea ice conditions were taken in the midst of the winter time, but we know that drone technology, battery lifetime and so on is an issue as you use these technologies in cold environments. So I say well below 0 degrees. Does it operate at -30? And if so, how long can you fly these instruments to support some of the remote sensing, remote sensing activities? Okay.
Thank you, Claude.
There were any points that I missed?
A remark, there is a need, I fully agree with you, there is a need to support the Calval activities, but not only in the Arctic region. For many other satellite activities, it's mandatory, in fact, it's an obligation.
Okay, well, that's a very rich set of summary of recommendations that were discussed, and it's a nice wrap up. I'm sure there's no more burning question because I don't see anybody standing up in line in the microphone, which will let us, Jean-François and myself, thank the effort that was kindly done by all the co-chairs. And now I suggest that we reconvene at 11:30 for a 20-minute coffee break for the second part of this last session. So enjoy the coffee. Back at 11:30. Cédric. On va changer un petit peu l'ordre. On va faire par la commission d'abord, puis sponsor. Donc, la commission, puis toi. Okay.
Comme il y avait mon nom, je me suis levé, moi.
Ouais.
No, I didn't. It's perfectly.
So there'll be a small change to the program. I don't know who had this awkward idea to put this order. So the three logos that you see here will speak, but after we get, let's say, what do we call it? Yes, a word, but let's say a closing remark from the European Commission. So Panos will first speak, and then GeoX will make a few closing remarks, but Peter is not here, so Cédric will do it. Thank you, Cédric. And then Knes, and then Isa. Thank you.
Thank you again, Jerome, and also thanks again for the opportunity also to see this summary also presentation this morning. And I would like a bit, as a closing remark from my side also to reflect to some of them and, to also highlight some of the key issues that I think will also is important also for our next thinking, on where to put also the focus and what are the issues to stress. The first thing I would also, I would agree, it was also mentioned several times also that the need also to improve also the linkages, also the strength, also the synergies between also the different communities. It was mentioned in particular also the, the data communities with science process communities, with stakeholders. I believe this is something which should be also a key for us. We always continue to highlight in our projects, which are, as I said, are collaborative projects, that they use the science not only to increase also the knowledge. I think this is, of course, something which is very important. But this is happening, you are also the best place also to do that. But our focus is more to create impact. So when also, and this is very important in our proposals, we defined what we call the kind of impact, intervention logic, where, we create some what we call, the expected impacts, at the program level. for instance, an expected impact is to improve better management of natural resources, or for instance, restore biodiversity. So these are, let's say, or the adapt to the climate change. So these are high-level impacts. And then we trying also to link also the what we create, the expected outcomes. So we develop what would be, what we expect that when the project is finished, how their results can be used and what will be the expected outputs, and how we would like also the projects to identify the way that these outputs can be linked, also contribute to the achievement of the impact. So this is very, very important, and that's why we always we encourage also this cooperation between researchers and users in the projects. So this is a very good opportunity in this context. The other also point I would also to mention is about it was also mentioned that some more emphasis on precipitation was apparently is needed, and I think this is something that emerged also recently, also in the discussion at the UN conference. This issue also came in the. There was an interesting also work done in this Commission of Economics for Water, where it was proposed to use, let's say, a notion of using the global hydrological cycle as a common good. I think this was the idea was proposed, and this is that we have also not to, because it seems the majority of the policies now are based on surface water management, and but what about if consider also precipitation, because this could eventually completely also change the way that we can manage also water. So I think this is something which is important. So this is important also to focus more also in this remote sensing Earth observation. This integrated water cycle view, I think this is, as I said, is important also with this digital twin of inland water, and how this can be also linked with the digital twin components. There are different components which are already under preparation. I notice also this the need also to improve the knowledge on anthropogenic impacts, on water use. I think this is, of course, this is important, and I would say what is also important is to increase also the data on water use, because I think this is some important limitation of current, global modeling exercises, that we don't have, really data on water use. And so we have to think how also Earth observation also can help also to provide this type of information. The issue on groundwater, so this is evolution, and I was pleased to see that there is also emphasis in the Earth observation community also, and the possibilities also to increase the use of Earth observation for groundwater assessment. This is eventually, groundwater is a very critical also issue. Finally, also noticing that the calls, to look more on the hydrology of specific regions rather than on hydrological, variance or quantities. I think this is, in my view, is also very important, and I would say also not only the specific region per se, but also look on the specific water-related problems of the specific regions, because I think this is the big debate now, how also to manage, the availability of the water. These are issues which are important to be focused. So I take this as a key messages from our perspectives, and I thank you again for your attention. Thank you.
Thank you very much, Manos. I think we can go now to the series of those sponsors. Welcome. Sorry, closing remarks. So Cédric David, In the name of GWEX, standing in for Peter, the GWEX in style.
Good morning, everyone. For those of you who were here on Monday, I already gave somebody else's talk. And so I guess I get to do it again. The only thing I charge, if you want me to give you a talk, is you just have to add my name in the title, which is what Peter did. And it's the first time I give a talk with my name in it. That'll be fun. Anyway, thank you remarks from GWEX. And please consider me the messenger. Please don't shoot the messenger. But as far as the thank you, heartfelt thank you for Jerome and Jean-Francois on organizing, and great time in Lisbon, and an amazing dinner. Thank you to all the sponsors. And if anyone took videos, please delete them. But so impressions from Peter, the future of altimetry is exciting, to say the least. With SWAT flying, with other excellent concepts like SMASH and other potential new instruments and platforms. Lots of inspiration from the work and the applications of Earth observations to water science. I think Peter's perspective was that a lot of what he saw or digested from our work here was very variable oriented, perhaps even single variable oriented, rather than systems oriented, which is, that's his perspective. And I think that's very much the GWEX perspective, to look at the Earth as a system at scales ranging from global to local. But let me expand on Peter's idea. I think what he likes to advocate for is consistent global data sets, assessments, and approaches, process focused rather than variable centric, and looking at the Earth as a system as a whole. So that means water, energy, carbon, cycles together and connected, which I think he was hoping to see more, but that's also his call for action comes with the extension of his hand. He's offering to get the GWEX community to participate in these Hydrospace meetings, and I agree with him that there would be value in doing that. I think Peter did note the value of the hydrology digital twin. I don't know if that was an announcement of opportunity or just the presentations that we saw. Is there an announcement of opportunity for digital twin of hydrology? No, I don't think so. Is there? There is? Okay, so then he's happy about it. And but he's advocating for a more global audience. And there are many GWEX projects that could benefit from coming here, and perhaps the community here could benefit from their expertise as well. And he's volunteering his help for collaborations. Last slide is advertisement for the upcoming GWEX meeting in Sapporo, Japan in July. And from Peter, thank you very much to everyone, and we're hoping to see you there.
Yes, we presented the digital twin. I mean, ESA is involved in the precursor of the digital twin and the 4D reconstructions of data that goes into the digital twin, and the Commission is doing that. So in hydrology, we have DTE hydrology, which involves many institutes and companies in Europe. No, it's been funded for quite some time. Is there someone left? Yeah, Espen can tell us.
Little precision, but for the DTE hydrology project, it's basically over. So there's no more funding of ESA for this project. But there will be I don't remember if it's already out now or if it's out or will come out very soon. It's a call more for generally for these digital twin components, where there will be also hydrology within.
Thanks, everyone. Okay, thank you, Cedric. And the next is the CNES. So Nicolas Picot will give us a few closing remarks from CNES.
Yes, thank you. Thank you to give me the chance to perform this short presentation on behalf of my colleagues from CNES on the programmatic board that we are not able to do it today. But Selma should actually like to thank you all to being there, to prepare our futures and to work in close cooperation on all aspects. And it was a very good meeting. So there might be some overlaps. With the GWEX presentation, I guess there will be some overlaps with the next one as well. First slide, thanks to you, and a very big thanks to Jérôme. Thanks you, Jérôme. Thanks to Jérôme, thanks to the team that organized this meeting. To me, it was maybe one of the best meetings in the last years, with a huge community, very good discussions, a lot of interactions, variables, observations, models, digital twins, validation, calibrations, newcomers, scientists, a lot of discussions during this full week meeting. A big thanks, Jérôme. It may be your last meeting, but we need to secure the futures. No, Hydro, you are not here. You're not Isamora, but we need to secure this kind of meeting devoted to hydros from space, not forgetting about in-situ data as well or any other means and models. So we don't do only hydro from space. Maybe we have to rename it a bit to include more of the in-situ networks in the scope. So Hydrospace 2026 is needed. To me, in 2026, why? Because we have the living planet in 2025, and we may avoid some overlaps. So it was, to me, a very brilliant, very active science community presenting different aspects from from retracking. Very simple, I would say simple, not simple. From level 1 aspect in terms of data processing up to a digital twin of the Earth. Every aspect of the processing has been addressed on different compartments of the hydrological cycles, from moistures, groundwaters, future missions, altimetry, including ISAT2, different teams, different skills, and it was very, very, I would say, promising. We have newcomers on development of applications that are coming. We did a lot of new progress on those variables, but we have still remaining challenges, and I will come back on that a bit later. We see studies on real application, real-time applications, as well like climate on the long-term records, spanning sometimes over 50 years, and it was very good. We have discussed and seen the complementarity between, I would say, Copernicus-like satellites, heavy, costly, numerous data set, complemented by newcomers, new space, and we have different teams in the room proposing some advanced or other methods to complement what is provided by Copernicus and the other research agencies, including CNES. Just we have to keep the link between those newcomers and the existing scientists, laboratories, and networks of people. Sometimes they work a bit alone, proposing their approaches, and we are not fully involved in their, I would say, thoughts or willingness to increase the system. We have seen some massive data processing. It was already addressed as part of some conclusion. This is a good approach. It's quite magic, but I don't trust in the magic approaches. We have to put some reality, and magic is not a part of our real world, and we have to be cautious. And I echo some remarks from this morning. AI is certainly a good approach, but we have to understand what is done by this kind of system, not using blindly. And already addressed as well, assimilation techniques, digital twins become reality. We have seen some promising talks. with many different models at different scales, approaches, making possible to perform, to move from R&D in the labs to some operational services like we did years ago for the atmosphere and decades ago for the oceans. It's a time to do it for the hydro. We are ready to do, thanks to you. We just need to perform it and to do it. We have still the lack of case spatial observations. It was mentioned every time. One-day revisit times with a smash lag concept or other newcomers' ideas is certainly a very valuable approach. GNSS reflectometry and other approaches are of interest. Calibrations and validation on the long term is absolutely vital. We need to make sure that we continue this effort to have error metrics on all data sets in order to give it confidence when you use the data for different applications. We do a lot of efforts on CNES side, but this echo my last bullet. Unfortunately, we still have a budget, but sometimes the budget is limited. Every time it is limited. We have a quite strong program on the French side, which is called TOSCA, to support the different research and laboratories. But the budget envelope is not enough to perform and to implement all the methods that you have in mind in terms of data processing and advances. And we see that we have also, I would say, not that many new students, PhD people in the groups. So we certainly need to prepare a future all together by having summer schools, training, advertising in the schools to try to grab those guys, those girls for the data processing of those future missions. It's become quite critical. And I know that on ESA side, they have also some, I would say, fears about the capacity to perform the R&D for future missions like Crystal, among others. And when we will work on the SWOT and other satellite merging approaches, we need people with skill and new ideas to perform those tasks. And to do so, we need some fundings. And CNES has some, but ESA as well. But maybe the envelope is not large enough. CNES for French-specific updates, SWOT is becoming publicly available. So now you can have access to it on the different portals, on Haviso, on HydroWave Next, on the product side, since yesterday. Yesterday evening, the SWOT have been publicly released. Be aware that those, I would say, beta pre-validated products have large concerns in terms of data quality. So it's a data set which span only 15 days for the hydro part that we have circulated just that you start looking at it in terms of format, but don't try to perform some, I would say, accurate analysis of those data sets yet. We have also a kind of virtual lab, which is ongoing development on CNES side that was advertised by Mathilde, and you have the poster on the right-hand side. So we welcome any French, European, or other people willing to work on our infrastructure, free of charge, with SWOT data, altimeter data, tomorrow Sentinel-1, Sentinel-2, and other Copernicus satellite data. It will be available to many of you if you like to process on your side, and we provide some support to help you understanding, merging, improving the data quality that we have in our hands today. And that's it. And I'd like to thank you again for this very interesting week.
Yes, I think supporting the young generation is something very, very important. We do need to invest. We do that at ESA with the advanced training course for the people who are already in at the university. And we also have programs to hire them, like young graduate trainee. And so advertise the people who are doing a master's that they can get an opportunity. Thank you very much, the French Space Agency, the member state of ESA. And now, now it's... so I knew that Panos and then Peter and Cedric and then Nicolas would have covered a lot of the content of the workshop, scientific details. So I'm not going to bore you by repeating more or less the same thing. And indeed, before them, we had a very rich and much richer than I had expected report on the wrap-up of the themes. Because, you know, people come and say, how can we, you know, it's, there's all these things, they don't fit in the same session. So, but finally, you see, I think the reporting was very, very rich. And now all we have to do is get our hands on a voice-to-text converter, and the report is written. So that's a big thank you to the effort that was done by the participant and then the co-chair. So what I can say is ESA is extremely pleased with the content of Hydrospace. We knew that when we saw the abstracts coming. In fact, it was quite laborious, you know, to try to shape a program, thanks to the scientific committee and the organizing committee, and the progress that was shown during the week. And like I just said, the unfolding of the discussion is really, really encouraging. And like many people will repeat all the time, we did it this morning, that the scientific community and the stakeholder community, the user community is very important, because if we didn't have them, we could launch washing machine in space, we would have the same results. So we need this feedback, and that's what drives us and helps us shape the future. So in response to the feedback we get, we can say ESA is committed to invest in, with the help of our member states, of course, the satellite missions to serve, that serves hydrology. And one example is that we didn't have much hydrology mission objectives since ERS-1, ERS-2, and VSAT, and so on. But now for the Sentinel Next Generation, we do have the mission objective. And of course, this is done with your support stemming from the discussion that I just said. And I mentioned also that we are now strengthening the coordination with the European Commission. And one example is, we can call it one of the flagships that we're launching. It's this competitive, open invitation to tender for the near real-time river discharge and flood forecasting. I think flood forecasting is really the thing that has a tremendous impact on society, and we should be able to make progress. And it's not easy in some cases, and much more. You have access to what we're doing. We have a work plan. We give it to the program board delegates of each of the member states, and it's their duty to inform you. And we do the open day once a year to tell you what we are doing in response of the user or the consultation workshops that we do, like this one. So this is just to tell you that there are a lot of satellites flying. There's the Copernicus and the Earth Explorer. I mentioned this in the opening statement. We're very fond of SWOT, and I think the synergy between Copernicus and Explorers and SWOT is very important. I just said that hydrology is a primary objective now of Sentinel-3 Next Generation topography. We would like to push the use crystal as much as possible over inland water. We'll see what's possible, but it was the same thing for CRISAT. CRISAT, it was a CRISAR mission. It was covering 9% of the planet, and shut up, don't bother us. And then we have the SARID mode, and then we played all throughout the mission to acquire patches, a big patch in the Pacific so we can observe the ocean. And CRISAT, for me, is one of the best oceanographic missions ever designed and operated and exploited. And of course, we're all looking forward the fundamental measurement of the displacement of mass on the Earth. And it's not just about trucks and trains, but it's the fluid envelope of the Earth, which is moving around. And that is very important. And I think MAGIC is going to be the next jewel in the sky, you know, after SWOT. And then, of course, we've said it, and we said it again. We cannot work in isolation. So we need, I forgot to add it, I thought about it later, but first the infrastructure to do the computing. I've been using my Unix box for a long time, and then you buy it, and then for 10 years you use it, and then one day there's a storm, it blows up, so you buy a new one, and you think the cost is very limited, but then when you look at the cost of computing, it has a big cost. And now data has a cost because of the commercial sector. Computing has a cost, and that has to be integrated and funded. So, maybe it's important that you realize that not only working hours have to be funded, but also these kind of tools, both data, which is open, free and open, but it's paid for before. But in the new space sector, you're confronted with expensive data that you would like to have. And in situ data, we've said it and said it again. Without that, we don't go very far, especially in the time sampling. The hydrologists, they have measurements every 15 seconds or every 5 minutes. And the Earth only spins in 24 hours, and the satellite goes only so fast that it goes around the world much too slow for many of the hydrologist requirements. And of course, putting everything into a model and trying to push the physics, use the physics with the data, and then forecast. So that's for sure. And for that, we count on the European programs to develop these things. At ESA and at ESRIN in Rome, we are launching the water cycle science cluster, and Espen Volden drove this special session on showing you what we do in this cluster and what we are going to do. And it was quite a full room. In fact, I thought nobody would be interested in these agency talks and so on, but in fact, it attracted a lot of people. We had to add chairs, and thanks for the support that we got from this place. Very flexible, very fast. And so we're looking forward to this beautiful document that we reuse and use again in order to shape the future and to seek for building a work plan that could be submitted for funding. And so this is going to be authored by all the co-chairs and the organizing committee. It's going to be published by ESA. I'm going to add DOI on it, so it will be easy to refer to. And send us now, in the days to come, any additional comment that you think of on the way back home. We can always take it on board. Among the many recommendations that we saw all throughout the weekend this morning, very well debriefed, I picked one, and I think sub-daily temporal sampling, if we want to do something as what meteorology is doing, for instance, I think it's one of the important ones. It's not the only one, but it's the one I decided to pick. Why? Because for that, we need infrastructure, and we need either densifying the ground system, which is extremely dense in France, for instance, Vigicru, but then every small town says my river is not covered, and my river is small, so it's even more risky, because when water arrives, it clogs the channel, and then we have a lot of casualties and so on. So I think the constellation of let's say the concept of the constellation of small satellites, of which you can always add more if you need a denser coverage, it's quite an interesting concept, and I'll be very happy if this can be flying. Especially that you can scale it. You pay for 5, and then you ask for somebody else to pay for 5 others, and you grow the constellation. And they are very small, CubeSats and so on. So ESA does a lot of effort in gathering the community, as you saw in the welcome speech. So I read the slide, but I modified it. I added this now almost past event called Hydrospace 2023. And I think we will continue. This award on what are the numbers. 270 people went to the website to register, put their name, and authorized us to keep their email address to contact them in the future from 45 countries. And then on site, we had 207 people, meaning that 183 were registered. And this is the fun part. 24 people did not register. So it's very nice for people register ahead of time. In fact, you can see between the intention to come and the desire to stay here and do this brainstorming activity and the possibility to come, it's not always, and the number of countries that did not come are countries which are actually remote, remote from here. I mean, certainly central to where they are. But that's why we decided to record the event, and it'll take us a couple of weeks, but we'll put it on YouTube, especially people in a different time zone. They can watch it and skip forward when it's boring and go back when it's really interesting and understand. So it's going to be on the YouTube channel of the conference system that we have. 233 abstracts is a number that I got from Lorenza, but I counted 269 at some point, so there were some withdrawals. There were some withdrawals and so on. And from 34 countries, so again, there's a wide spread of origin, and we're quite happy with that. So, Nicolas showed on his slide, he called it 2026, I don't know what, because when we did it in 2023, we said, let's do it in a couple of years, and it was 2027. It was really hard to gather the hydraulic community, and then there was a long time, and we were in Vienna in 2024, and we did the call from Vienna, like l'appel de Vienne, like maybe like Charles de Gaulle did from London, and people said, no, we know what to do, we don't bother, and so on. In fact, it's very important to unite this community. And I can tell you the ocean people, one ocean, one people, it's really easy to unite. The hydrology people, it's a little bit more difficult because one river, one people, another river, another person, and so on. And don't let time go by. And between 2007 and 2015, we didn't manage. So how do you organize this workshop? There's no trademark. It doesn't belong to any company or any agency. In order to organize a workshop, it just takes 10 minutes. The first stupid guy, the first guy who's putting his finger in the machine, in the mixer, whatever it's called, to make a good smoothie, you just have to send an email. Hey guys, when, where, and who wants to be in the core team? And then it gets organized. So sometimes you don't get an answer for a couple of months, and you resend it. Hey, remember a couple of months ago. So who can organize 6 Hydrospaces? The person that will send this email to a happy few that they've met here and say, so let's do it. And then when? Not in 10 years. Maybe in September or November 2025. Because we organize Living Planet Symposium, and 3 or 4 months before and after, we don't want any workshops because the limelight is on the symposium, and that's going to be in May. Traditionally, it's always in May. And so if we organize something in September or November, maybe next to an OSTST or something like that, and then where? So it can be anywhere. Probably in a place which is decided by this group of core people that get together. And then what? And then, of course, there's a what, meaning let's shape an objective, a series of objectives and themes. And then there's one thing I didn't write here, but you can imagine who pays, okay? So we'd like to think of that. So it's up for grabs. It doesn't have a trademark. And let's hope that it will be organized. If not, I'll have to do it. Yeah. It's a hard job, but somebody's got to do it. Continuing gathering the community, I showed you this slide. We make an effort on the altimetry part, one of the instruments which is important for our activity. And so I give you an appointment in Montpellier from Monday 2 to Saturday 7, because I booked Saturday 7 because of what Nicolas said. We need to do the training. We want a day of training, and I think training on SWOT, training on fully focused SAR, and these kind of things on altimetry is quite necessary. And we do that systematically with the coastal altimetry workshop. We didn't manage to do it this time around, but we should always add a day of training either before, so people understand better what's going on during the week or after, because they've seen what you can do, and then they want to know how to do it. And so if you want to stick that on your door, there are some left. So now it's the series of thanks I cannot avoid, and I would like to first thank the partners that joined ESA for organizing this 5th edition of Hydrospace, the organizing committee at large, and the scientific committee members, which helped us plow through the 269 abstracts in the beginning. And then I would like to thank very, very warmly the co-chairs that did an excellent job. We saw it this morning, and we're looking forward to the report. I'd like to thank the European Commission to be with us. I'd like to thank Panayotis Balavanis for the welcome and the keynote this morning and the closing remarks. I would like to give a heartfelt gratitude, extend heartfelt gratitude to our local member of the organizing committee. If she was not here, we'd probably be in another country for political and whatever transboundary reasons. And so we managed to do it here. And thank the sponsor of the dinner. It's really nice not to have to collect 200 and distribute 200 receipts and so on. It's so nice that it's offered by a sponsor. And it seemed that everybody enjoyed it. So thanks to the Operational Space Hydrology Center Consortium, the French Open Initiative, and you recognize them on the picture. Thanks, everyone in this consortium. So now I'd like to say a special thanks to Lorenza and Francesca. And when we're in ESRIN, I wake up an hour early and I go around town to find flowers, and I give them flowers. So here, Francesca and Lorenza, here are the flowers that you deserve, but you're flying back, so it's not very appropriate. And so also we'd like to thank the work which is done by the Graphic Bureau. You see all this decoration that you have. So there's people like Georgia and Ornella are extremely helpful in doing that. I'd like to thank Marco Restano, my right arm and my left arm, and if I had a third arm, it would also be the third arm, without whom I would not have been able to do all I have done and all that we have done. And so I thank him very much. And then I would like to make a pitch. We advertise visiting scientists coming to ESRIN in the Science Hub. Research fellows, we try to put out a postdoc fellowship, but if you have your own fellowship, you can come. And so please talk to me about that. I'll explain to you how it works. And then also, I think that this is a big success. I'm extremely happy, very
Sorry. I think we can do a standing to applaud Jerome. It will be much better.
Thank you very much. Let me just take the words out of the mouth of Nicolas because I'm speechless. I would like to say that this was one of the best workshops, and I really appreciate the workshop style. It's so much better than anything you can cite, like EGU, AGU, IGARS, COSPAR. Well, COSPAR is very special. It's dear to my heart because it's really a good north house with a lot of capacity building and a good way to have an international collaboration with people that you would never meet because they either don't get to Vienna or to San Francisco and so. But these workshops start with the discussion and so on. And I think we should have 45-minute coffee breaks and not 30 minutes because it's too short. So thank you very much. I have a few more slides that if you want a certificate, please ask for it. Lorenza will send you a PDF. Eventually, if you come to ESRIN, we'll print it for you, but we don't want to pay the shipping and handling and spend all that fossil fuel to get that piece of paper to you. I'm sure you can handle the printing if you wanted to. So and then a big personal big thank you of the unscheduled special session. And there's some culprits here in the room, and I really thank them, in particular Marco and Jean-François and Angelica, who made me cry. And the forest, thanks really for the forest. I appreciate that. Have a safe journey home, and if you have 3 best pictures on your cell phone, you can email them to me. So thank you very much. Thank you very much. Eh bien voilà. What? And now we have to have the elevator music too.